We're going to be looking at proving triangles congruent with angle, angle, side, side, angle, and the HL theorem. The first two are pretty straightforward since we've already kind of talked about how to prove triangles congruent. The first one, oh boy, that's a really bad triangle, sorry guys. The first one is like our side, angle, side. As I start drawing two sides, your angle and your sides, how it corresponds there is you're going to have the side be congruent in the middle of your two angles. Technically, you need a second triangle with this, which is going to follow that same format. Angle, angle, side, this is where the side that's congruent is not in the middle. So it'll be either one of those. This is kind of nice since we don't have a double side where the angle is not in the middle. So this is just the reverse of that one, or reverse of which we don't have, I should say. So you're just looking at your different angle pairs and your congruent sides and figuring out which congruence theorem is applying. So on A here, we have those two right angles. We know that right angles are congruent to each other. There's a theorem. We have right angles congruence theorem that says that. We've talked about it before. It's kind of straightforward, but one of those deals. But we do not have a AAA. So this situation is neither. For B, we have a side that's shared, so we know that that side's in the middle. So we have angle, side, angle. And on C, we have a bow tie picture, so we're going to have vertical angles there, which means that they're congruent, and our side is not in the middle, so we have angle, angle, side. Now, moving on, there's some typos here on example 2. I'm sorry. This should be a perpendicular sign, not a congruent sign for both of those two. So when you're filling out your proof, because I know how this is laid out, write all of your given information in one box, and then we'll move on from there. So BC is congruent to EC, BA is perpendicular to CA, and ED is perpendicular to CD. That's given. We have our proof statement. Now we need to go from here and kind of figure some of this stuff out. Because we have perpendiculars there and we have right angles, we have to say that the right angles are congruent to each other. Now I know that seems kind of redundant, but it's one of those things that you have to prove that those right angles are congruent to each other. Just because they're right doesn't mean that we can assume that in one triangle it's congruent to the other. So we actually have to prove it. I know it seems kind of crazy, but it's one of those deals. So we have angle BAC is congruent to angle EDC. Again, it's the right angles congruence theorem. I have it in our proof help at the end, but just so you're aware. So we've got our right angles congruent, and then we do have a bow tie picture. So we have vertical angles. And that's angle ACB to DCE. And I can see here my options are side, 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 angle, angle, side, or angle, side, angle. Looking at just the one triangle, the side is not in the middle of those, so it's angle, angle, side. On example 3, there's a couple different ways that you could go about this. You could do this in 3 steps, or you could do it in 4, depending on what your goal is, based on the parallel lines. So let's start off by going ahead and filling out the information we already know for a proof. So we already got 3 of the 8 boxes filled out. So with that parallel line, so parallel lines, if you're looking at the proof help, says that you need to use alternate interior angles, which is true. What's interesting about this picture is your alternate interior angles could be applied to 2 different sets because you have 2 transversals. So our parallel lines are here and here. You could have line DC as your transversal, Or you could have AE as your transversal. That then changes some things, and you can have, like I said, two different sets. So the first one is this angle D and C, or you could have angle A and E. And the reason why I can use just the letter D or the letter C or the letter A or E is because there's no other way to get that angle. Whereas if you say angle B, that could be option 1, 2, 3, or 4. Just an FYI on the lettering there. But we're going to go ahead and use consistency there. The other thing that you might have noticed is that you technically have a bow tie. So you could realistically also use vertical angles, but with the AIA, you're going to cover both of those. So I'm going to go ahead and use the AIA on both of mine, and I'm actually going to split this. Even though you could technically write it in one box all together as one, I'm just going to split it for visualization purposes. So we have angle ADB, so really angle D, matches up with angle ECB, and that's that one arc mark. Then we'll go with a 2 arc mark. Angle DAB, which matches up with CEB. Now, taking out that green there, looking at this, my congruent side is not in the middle because it's right there. Therefore, I have angle side. If you would have used vertical angles, depending on the angle pair you used from the alternate interior angles, you could have actually had ASA, but again, it kind of depends on which angle pair you went with. Then there is a another way to prove triangles congruent. That's the hypotenuse leg theorem. This is only with right triangles. And what this is you need one pair of legs congruent, and we'll talk about a picture. The hypotenuses must be congruent, and you need 2 right triangles. So if you're talking about a right triangle, just a refresher here. In a right triangle, one angle is 90 degrees, and on the opposite side is your hypotenuse. The other sides are considered legs. Sometimes those are congruent, sometimes not, just depends on what you have. So the nice thing with this is it kind of gives you a check mark or a checklist that you have to have these things in order to make them prove that you have your 2 triangles are congruent. Again, I'm sorry, example 4, another typo here. Instead of a congruent sign, it should be a perpendicular. So let's go ahead and write our given information, again, all in one box. So looking at this, I already know PS and PQ are the hypotenuse, so I already have that done. We're good. Now I need to work on a leg. Well, I've got an overlap, so I know right away reflexive. Got to use that. Try to use that as much as I can. So we have PR is congruent to PR. Now, I don't have anything that explicitly states that I have right triangles, so I actually have to state that. So triangle PSR and triangle PQR are right triangles. And that's the definition of right triangles. Since it's PR is perpendicular to SQ, I know the marking only shows it in triangle, the top triangle, but technically the perpendicular sign would be on both of those. So we know that those are going to be right triangles since we have a right angle in both of them. Example 5, and the last but not least, HL theorem by default, since that's what we're working on here. Example 5, again, go ahead and fill out the stuff that you know. So we've got our top line and our statement on the last line. So again, we already know that this is going to be HL theorem, but let's just go through the process anyway. See that we have an overlap or a shared side. So we know right away we have a reflexive. So reflexive property, MQ, and looking at my lettering here, lettering does switch, just to make sure that we have our letters correct. So right now we have a leg congruent with MN and PQ. We have our hypotenuse congruent, but we need to explicitly state that our two triangles are right triangles. Definition of right triangle. And then this is our HL theorem. So those are all the different ways that we can prove triangles congruent: side, 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 angle, 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 side, and HL theorem. We're going to go a little bit more in depth with that as far as what else can we use from triangles, looking at isosceles triangles specifically in the next section, and what we can use after we prove the triangles congruent, what can we use from that.